Hello, how's everybody doing? The last thing we're going to ask you to do this week is to try and find the area of a certain polygon given the radius of a circle that it's inscribed in, that it's inside of. So in this example, we have a pentagon with a radius of 10. The one you're doing is going to be a decagon, but this will walk you through all the same steps. But in this case, I have a 5-sided figure, right? It's a pentagon, so I'm just going to write 5 above it, right? Because I have a 5-sided figure. So what I want to do is I want to follow these steps. These are my recommended steps for you. Step 1, label and find angles. So I see that I have a radius of 10. Now remember, radius goes from the center of the circle out to it. So I'm going to put my 10 right here, right? 10 units, 10 centimeters, 10 whatever. Now, I think we should all know by now that we are going to try to chop this figure up into triangles, right? Whoops, it's a little off there. All right, so basically, guys, if we could find the area of this triangle, right, there would be 5 more of those. I'm not going to draw all of them because I want to focus my attention on this one, okay? So if I could find the area of that triangle, I'll multiply it by 5. But let me label whatever I can here. Label and find angles. So I labeled the radius. Now I want to find the angle measures, and I'm going to start here, okay? Think about it, guys. If this is a pentagon, I would have 1, 2, 3, 4, 5 central angles if I drew all of the triangles. So in order to find this angle here, I'm going to take 360, right, because that's all the way around, and I'm going to divide it by how many central angles there would be, how many triangles there would be. So 360 divided by 5, right, gives us, whoops, it would help if I turn it on, right? So 360 divided by 5 is 72 degrees. So that means that angle in the center, this central angle is 72 degrees. Now remember, this is a perfect polygon. It's a regular polygon. So that means these two side lengths are the same. So maybe I'll put a 10 there as well. So if this is 72 degrees, then I'm going to take my calculator, right? I'm going to subtract 72 from 180. That means there's a, what the heck am I typing? 180 minus 72, sorry. So that means I have 100, this is 72 degrees, and there's 108 degrees left over. And I'm going to split those equally. So I'm going to divide that by 2, which makes each of these angles 54 degrees. Okay. So now we're almost ready to go here. Later on, I'm going to need, well, you know what, let's talk about this right here, all right? So there is something else I'm going to do with that angle, but my step 2 is to come up with a plan. Now, ladies and gentlemen, a plan for us is just going to be a formula. So if we want to find the area of the entire pentagon, then what we're going to do is try to come up with an idea here for a formula. So if I just do 1/2 base times height, that'll get me the area of the triangle. So what I want to do next is I want 5 of them. So I'm going to multiply that by 5. You can put that in the front if you want. Okay, so this gives us our idea. So what are we missing? Do we know the length of the base? No, we don't. Actually, do we know the height too? No, we don't. So what I'm going to do is I'm going to draw the height perpendicularly down from that center point. Okay, now that's going to be my height. Okay, but I don't know it yet. So what we're going to need to do here is we're going to need to use trig to find our information. So I'm going to call this A, and I'm going to call this B, okay? Now, be careful. The base is going to be 2 of those. So here we go. Ready? If I'm looking from 54 degrees, the height, or A, is opposite. I know the hypotenuse. SOHCAHTOA, right? Opposite hypotenuse, that's sine. So what I'm going to write here is the sine of 54 degrees equals opposite over hypotenuse. So that's going to be A over 10. Okay, now I'm going to have 2 of these equations. The variable's up in the numerator, so what I could do is I could, if you wanted to, I could turn this into a proportion and cross multiply. 1 times A, that's easy, that's just A. 10 times sine of 54 is sine 54, oops, excuse me, 10, being sloppy today. 10 sine of 54, so now I'm going to just grab my calculator and approximate that. So I'm going to clear that out. 10 sine 54 degrees, close it. I get about 8.09. Okay, 8.09. Now let's think about that. Yeah, that makes sense, because if 10 is the hypotenuse, that's got to be the biggest side. So I think that makes sense, about 8.09. All right, so that gets me the height. So remember, guys, this was our plan. So I just figured out the height. So what I'm going to do is come down the bottom here, and I'm going to write my formula out, right? I'm going to put the 5 in front now, right? Just put that out in front. So I'm going to have 1/2 times the base, which I don't know yet, times the height, right? So the height we just found to be about 8.09. So the only bit of information I now need is going to be the base. So if you notice here, I'm focusing on this left side, right? I'm not using the whole triangle, I'm using the right triangle. So 54 degrees, where is B? That's adjacent. Where is 10? That's hypotenuse. Think about it. SOHCAHTOA, adjacent over hypotenuse, that's cosine. So I'm going to have the cosine of the angle, 54 degrees. Remember what we were doing before break, guys? Remember we were drawing a little stick figure dude? So adjacent over hypotenuse, so that's cosine of 54 degrees equals B over 10. Looks similar to this one, right? But it's cosine instead now, right? So I'm going to cross multiply again. That's going to give me B equals 10, 10 cosine 54 degrees. Now I'm going to grab my calculator. Okay, I'll clear that out. 10 cosine 54 degrees. That's going to give me about I'm going to call it 5.88. Okay, 5.88. But ladies and gentlemen, be careful here, right? 1B. B is about 5.88, but that's only half of the base here, and this is a common mistake. Be careful. So I want the whole base, so that means it's going to be 2 of them. So I'm going to write down that the base is about, let's take our calculator. I'm going to leave those decimals on there, times 2, right? 11 point, let's call it 11.76. Okay, now that was our height. That's our base. I'm going to go put my base in here. All right, so now I'm going to multiply. Now, guys, at this step here, it's really just all calculator work, right? So what I'm going to do here is I just want you to see the area of the one triangle first. So I'm going to type in, here we go, 1/2 times the base times the height. 0.5 times 11.76 times 8.09. So the area of one triangle is about 47.57. 47.57. Okay, now remember, that would be the area of just this triangle. What do we do to find the area of the whole pentagon? We multiply it by 5, right? Because there would be 5 of those. Times 5. That gives us about 237.85. 237.85. And I'm going to write units squared. Okay? Now, when you're finished with your project, you're going to type that in on the Google document, or if you want, you could just literally write your work out on paper and then take a picture and post that on there. All right, I hope this helps, guys. This is part 1. There will be another example after this. Good luck. Thank you.